In this video, we are going to be looking at negative binomial distribution. You can do well to click the subscribe button, to get notification for our videos. Okay, so here we can see the probability distribution function of a negative binomial distribution, which is this x minus 1 combination r minus 1, then p raised to power r, then q raised to power x minus r. Then here we have the mean of a binomial distribution, and the mean is 1 over p. And the variance of a binomial distribution is rq over p squared. Now don't forget, p is the probability of success, q is the probability of failure. Okay, and remember that the random variable x represents the number of Bernoulli trials up to and including that in which the rth success occurs. Okay, that is what x represents. The special case r equal to 1 gives the geometric distribution. In our previous video on geometric distribution, we said that it has to do with the first success. But in this case now is the rth success. That means a number of success, under a Bernoulli trial, representing a Bernoulli trial. Okay, so we can see here also that the negative binomial distribution describes the probability of x trials that are made before rth successes are obtained. X trials are made before rth successes are obtained. Okay, so what that really means is the number of successes or the number of failures you must have had before a particular number of success. Okay, so we are going to see a question here, some questions here. The first one here, we have, you are surveying people exiting from a polling booth and asking them if they voted independently. The probability P that a person voted independently is 20%. Okay, so that means your P is equal to 20%, which means 0.2. Okay, what is the probability that 15 people must be asked before you can find 5 people who voted independently? 15 people must be asked before you can find 5 people who voted independently. You see, so we have 15 trials before 5 successes. In that case, now we say that our x is equal to 15. Then our r here is the number of successes, which is 5. Now your q is obviously 1 minus p, which is going to be 0.8. Okay, so according to the principle, we are going to have x minus 1 combination r minus 1, then p raised to power r, then q raised to power nx minus r. Okay, so that is going to give us your x minus 1 means 15 minus 1, that means 14 combination r minus 1 is 4, then your p is 0.2, 0.2 raised to power r, your r is 5, then your q is 0.8 raised to power x minus r, your x minus r there is 15 minus 5. Okay, so you can use your calculator to get the answer. Now we see another question here. Customers came into a store, 30% of them makes a purchase. Okay, so A, calculate the probability that the second purchase is made by the 6th customer. The second purchase is made by the 6th customer. In this case here is also a case of negative binomial distribution. Our probability of success is 0.3. That means the probability of customers that make purchase is 0.3. That means your Q is definitely 0.7. Okay, so your X here is 6 and your R here is 2. Okay, so we have, that means we are going to get 6 minus 1 combination 2 minus 1. Okay, then P 0.3 raised to power 2, then your Q is 0.7 raised to power 6 minus 2, which is 4. Okay, so that is what we get. You can use your calculator to get the answer. Now the next question here says, Calculate the expected value of the sequence number of the customer who makes the second purchase. The expected value there means the mean, that means expected value of x, and that is simply 1 over the probability of success. Sorry, we see that here 1 over the probability of success, which means 1 over 0.3, and 1 over 0.3 there gives us 3.33. So that's the answer to the question.